Hello everyone. Today the topic which we are going to discuss is gravitation. We would have come across this term in many occasions, but what is happening in this gravitation? What are the force that is acting between these two? That is what we are going to analyze today. But before going on to the topic, let us see some basic things how gravitation works. We all know that Earth is a huge mass. Earth is a huge mass, and if any object, you can take any object, a ball or anything, if you keep above the surface of the earth, what happens is a force will pull that object and that object will fall towards the earth. Based on gravitation, we know that each and every object in this world will have an attractive force between those things. Here, this is object 1 and this is object 2. Since there is an attractive force, you should know, you'll have a doubt that even Earth should move towards the object. But when we compare the masses between Earth and this mass will be much more lesser. This is m1 and this is m2. m1 will be much more lesser than m2. Therefore, when mass is lesser, automatically acceleration will be from mass m1 towards the earth, that is mass m2. We know that force is equal to mass into acceleration. Therefore, if we keep acceleration on the same side, and if we move the mass to the opposite side, you will get force by mass. Mass is inversely proportional to acceleration. Therefore, if mass increases, acceleration decreases. Since mass of the earth is high, therefore earth will not accelerate towards the object. Only the object will be accelerating towards the earth. This is what is happening in the earth. That is, whenever we lift an object from the surface of the earth to an upper position, if we leave the object, that object will fall to the ground, not the earth will move towards the object. Okay. Now we'll see how much amount of force, what is the equation for forces and definition of gravitation. Let us see now. See, let us take two masses, mass m1 and another mass m2. Let it be m2 and let it be m1. These two are separated by a distance d. The distance should be taken from the center of the two masses. We should not take at the edge of two masses. We have to take at the center of two masses. This is the distance d. It is separated by a distance d. Therefore, what happens is, since we know that whenever two masses are brought nearby, attractive force will be generated between these two masses. That force is called as gravitational force. We are going to analyze this force. Before analyzing, the parameters that is involving in forces, we know that these two masses and the distance. These are the two things which we know. Therefore, based on this, we are going to calculate the gravitational force. Because if the mass is increased, means what happens is, if the masses increases, what happens? The force between these two will also get increased. If the mass is increased, force between these two will increase. Therefore, product of masses will be directly proportional to gravitational force. Therefore, gravitational force is directly proportional to product of two masses. This will be your first equation. Then coming to second equation, there is another parameter, distance. Whenever we increase the distance, the force between these two masses will get decreased, because whenever we make a distance, whenever we increase the distance, the force between these two will get decreased. Therefore, gravitational force is inversely proportional to distance. See, distance from mass 1 to mass 2, that is d, and distance from mass 2 to mass 1, that is also d. Therefore, product of two masses, that is d into d, you will get d square. This is called as inverse law, inverse square law. Okay. Therefore, these are the two parameters that is linking the gravitational force. Therefore, by linking these two equations, you will get gravitational force Fg is equal to, that is directly proportional to product of two masses and inversely proportional to square of distance between them. To remove this proportional, we are using a constant, that is gravitational, universal gravitational constant, that is Fg is equal to proportionality constant g into mass 1 mass 2 divided by square of distance between them. This g is called as universal gravitational constant. It can be applied in the overall universe. You can apply it and analyze the gravitational acceleration of Earth or Jupiter or Saturn, anything you can analyze. To identify this, Lord Cavendish, using a balance mechanism, he has identified the constant for G. G is 6.673 into 10 to the power minus 11. The unit should be identified by, keeping this gravitational constant G on this side, and we are moving these two things on the opposite side, you will get G is equal to Fg into d square divided by m1 into m2. Unit of force is Newton. Unit of distance is meter. Since there is a square, it is meter square. Divided by mass 1 is kg, mass 2 is kg, that is kg square. Therefore, this equation becomes, this unit becomes Newton meter square kg per minus 2. Therefore, this unit will be Newton meter square kg per meter square, kg per meter square. This is the equation for gravitation, that is force of gravitation, and the universal gravitational constant 6.673 into 10 to the power minus 11. Okay. Thank you.